problems. If you have Hi friends, Mrs. Garcia here. Today's lesson is all about decomposing and composing fractions greater than 1. Let's begin. Say this fraction with me. 7/3. Now this is one way to represent the number. Can you think of another way that we can represent this fraction? We can represent it as a mixed number with a whole number and a fractional part. We can see that the unit is thirds. Think, how many thirds make 1? You're right, 3/3 makes 1. Let's count by 3/3. 3/3, 6/3, 9/3. Ooh, too much. We need to stop there. We only have 7/3. We can decompose 7/3 using a number bond. 7/3 is the whole. Now, earlier when we were counting, we know 3/3 makes 1. 6/3 makes 2. Let's show 6/3 as one part of 7/3. What's the other part? 1/3. Let's now use this number bond that we've just created to write an addition sentence for 7/3. 7/3 equals 6/3 plus 1/3. Let's now rename using whole numbers. We know 6/3 equals 2. So 6/3 plus 1/3 is the same as 2 plus 1/3. We know that 7/3 equals 2 and 1/3. Let's use a number line to model this. Go ahead and on your paper, draw a number line with endpoints of 0 and 3. Let's now decompose each whole number into thirds so that we can plot 7/3. If you recall from our number bond, 6/3 is the first part. So we're going to start at 0 and jump to 6/3. What does 6/3 equal again?
This is the
2. And we can see that it equals 6/3 because when we count 1/3, 2/3, 3/3, 4/3, 5/3, 6/3 lands right at the number 2. Now our other part is 1/3. So we make one more jump to 1/3. And so we can see that 7/3 is equal to 2 and 1/3. Our next fraction is 13/5. Think, how many fifths make 1? 5/5 make 1. Let's count by 5/5. 5/5, 10/5, 15/5. Stop. We only have 13/5. So we'll decompose 13/5 using a number bond. 13/5 is the whole. We can show 10/5 as one part. Think, what's the other part? 3/5. Let's use the number bond to help us write that addition sentence. 13/5 equals 10/5 plus 3/5. I'd like you to now pause the video here and rewrite this addition sentence and rename using whole numbers. We'll compare when you return. Welcome back. Here you can see I've renamed 10/5 as 2. So our new addition sentence is 13/5 equals 2 plus 3/5. In other words, 13/5 equals 2 and 3/5. Just like before, let's go ahead and use a number line to model this. I'd like you to go ahead and draw a number line with the endpoints 0 and 3. Let's decompose each whole number into fifths so that we can plot 13/5. We'll start at 0, and our first part is 10/5. 10/5 equals 2. So from 0, we jump to 2. And again, we can count to be sure. 1/5, 2/5, 3/5, 4/5. 5/5 equals 1. 6/5, 7/5, 8/5, 9/5, 10/5 equals 2. What's the other part? 3/5. So from 10/5 or 2, we'll add 3/5, 1/5, 2/5, 3/5. So 13/5 equals 2 and 3/5. Our next fraction is 7/3. Think, how many groups of 3/3 are in 7/3? If you need to, count by 3/3 on your fingers. There are 2 groups of thirds in 7/3. We can write 2 groups of 3/3 as 2 times 3/3. How many thirds remain? 1/3. 2 times 3/3 equals 2. And then our 1/3 remains. So what's 2 plus 1/3? 2 and 1/3. So 2 and 1/3 equals 7/3. Let's try another. This time, our fraction will be 10/4. Take a moment and think, how many groups of 4/4 are in 10/4? There's 2 groups of 4/4 in 10/4. Go ahead and pause the video here to record a number sentence to show 10/4 as a mixed number. We'll compare our sentences when you get back. Welcome back. Go ahead and take a moment to compare your number sentence with mine. You can see here I wrote in parentheses 2 times 4/4. The other part is 2/4. So I have 2 plus 2/4. 10/4 equals 2 and 2/4. Watch now as I reveal this math sentence written a new way. I'd like you to go ahead and pause the video again, and this time I want you to share out loud what you notice about this new math sentence. We'll share our noticings when you get back. So, what did you notice? We can see that the 2 is in the numerator. Now, if we multiply 2 times 4, we get 8. So 8/4 is the same as 2 times 4/4. I'd like you to now try this on your own. Let's try with the fraction 12/5. Go ahead and pause the video here to convert the fraction 12/5 as a mixed number using multiplication like we did earlier here. We'll compare our work when you get back. Welcome back. Here you can see that I converted 12/5 to the mixed number 2 and 2/5. Here you can see I have 2 groups of 5/5, which I wrote as 2 times 5/5. And then the other part is 2/5. That equals 2 and 2/5, which is our mixed number here. We're ready for today's problem set. Your must-do problems are here on the screen. Go ahead and set a timer or watch the